Okay, so we're going to look at this question. This question is from 2006, paper 2A, question 4. Okay, so let's read the question. Figure 1 shows a ray of light traveling from air into glass. The incident ray makes an angle of 50 degrees with the boundary. Some of the light is reflected at the glass surface, but most passes through into the glass and is refracted. The refracted ray makes an angle of 65 degrees with the boundary. Now this question looks simple enough, but there are some trap in this question that you need to be a bit careful about. Is that actually this question has two parts. Number one, the light rays, most of the light rays are refracted, but they also mentioned that some of the light rays are reflected. Now many students are aware that light rays will be refracted in glass, but they are not familiar with the idea that the glass can also reflect. Now this reflection is not total internal reflection, because this is from less dense to more dense. From less dense to more dense, total internal reflection cannot happen. So what is this reflection? Let me show you a calculator again. So this calculator is actually a simple plastic calculator, but although it's plastic, it has the same kind of reflective surface as glass. So glass and plastic in similar fashion has this property that although light ray can pass into the glass, there's also some light ray, like for example you can see this this reflection of the fluorescent light. Some of the light ray is reflected back out. So refraction and reflection happens on a reflective surface. Okay, so let's move on. So when the other thing you need to be aware of is that this angle of 65 degrees and this angle of 50 degrees are not your incident and refracted angle, because the incident and refracted angle has to be made with the normal. So the very first thing you need to draw is the angle of the normal, so you need to draw the normal, and the normal is 90 degrees. Okay, so after you draw the normal, the next thing you need to do is you need to indicate that this is actually my angle of incident. So the angle of incident in this case will be 40 degrees. Alright, so let's label it I. So we know that there will be some rays that are being refracted. Okay, so that means that in this question, since the first one is only 1 mark, you do not need to draw to scale nor to show how correct is your answer. You just have to draw a ray, okay, that bend towards the normal. Why is it so? Alright, we need to remember this characteristic. Okay, if it's traveling from less dense to more dense, okay, it will refract or bend towards the normal, and the formula is n equal to sine I over sine r. So with this knowledge, because this is less dense, this is more dense, so the light ray that is incident here will bend towards the normal. So once it crosses the boundary, it bends towards the normal. So this is the normal path that it goes, it will bend towards the normal. So that will be the answer. You do not have to be correct to the angle, you just have to draw this. But this is not complete, because you need to show the reflected and the refracted ray. So what's the reflected ray? The reflected ray will be the same in angle of incident is the same as an angle of reflection. So this will be the reflected ray. So it will be 40 degrees also. So remember, this R and this R is different. This is reflection, or this is refraction. Okay, so that is the two rays that you will see. Okay, so calculate the refractive index of the glass, state clearly the formula. So this is a very interesting question. How are you going to do it? So look at this diagram again. Okay, the question says that it makes a boundary of 65 degrees. So if it makes the boundary of 65 degrees, that means that the angle here must be 25 degrees, right? Because this is a total of 90 degrees. So, in other words, okay, if we calculate this answer, okay, the angle of incidence will be equal to 90 minus 50, alright, and the angle of refraction is equal to 90 minus 65, which is 25. Angle of incidence is 40, so using the formula n equals sine I over sine r, you get n equals sine 40 over sine 25, which give you n equal to 1.5. So that's the answer for part 2. Okay, so the next question is, alright, let's move to the other parts of the question. So this question is asking in the arrangement shown in figure 1, it is not possible for total internal reflection to occur whatever the angle of incidence. Explain why total internal reflection cannot occur. So this is a very simple question, alright. The answer is simply light ray is not traveling from a denser medium to a less dense medium, because total internal reflection only happens if it's traveled from glass to air and not from air to glass. Simple as that. Next question, define critical angle. Alright, critical angle is actually very similar to the answer of what is the criteria for total internal reflection, but it's just a bit twisted. So look at this answer, but before I show you the answer, just remember, critical angle happens when the angle of incidence is equal to critical angle, and when it happens, the angle of refraction is 90 degrees. So this is the foundation for the definition of critical angle. So let's look at the definition. It is the angle of incidence in the optically denser medium, alright, angle of incidence, where the angle of refraction in the less dense medium is 90 degrees. So there are 4 parts to it. Angle of incidence in optically denser medium, angle of refraction in less dense medium is 90 degrees. So that's the answer for part 2. Okay, so that's all from me. Thank you.